Hello, this is Gary Flisspart. I'm introducing one of the uses of the GLFPE, or the GLF Programming Environment, live boot Linux disks. You can run a complete environment from the GLFPE live boot disks that provide you with a variety of programming tools. Well, one I want to demonstrate today is the Arduino Integrated Development Environment, or IDE. If you're familiar with making maker spaces, the Internet of Things, and other things, you may be familiar with a small microcontroller that's fairly accessible by average people. They cost around $30 or so. They come in a variety of forms. Here's an example of one that I have. It's a clone of an Arduino, a knockoff, shall we say, called a Diabolino. It has the same microprocessor in it, the Atmega 328P, that an Arduino would have, and so it works pretty much the same. The advantage of these things is you can write programs to control a variety of hardware in the real world, turn things on and off, control motors. Blinky lights are the easy thing to do, and I'll demonstrate blinking lights because that's the usual way to demonstrate how to program one. I've already brought the environment up, but just to show you how I get it to the menu under electronics or even under programming, it's duplicated in the menu. But the menu brings up this IDE, and if you plug in, I'm going to turn off the camera on the Arduino. If you plug in the Arduino, or Diabolino in this case, to the USB port to recognize the serial port that runs it, and turn it on, you can see here that what it's running right at the moment is a sketch that blinks, a program to blink a light. In this particular case, about half a second on, half a second off. I'm going to show you the program. Under the sketchbook, I have a blink test program, and in this particular case, I'm using this particular program. Now, this program is written in a language called processing, which is really a variant of C++ with some relaxed rules. You can write programs for it in pretty close to C as opposed to C++, but it'll recognize things like the double slash comments that C++ does. Say treat it as C++ for the libraries in particular, and you can treat the sketches as either C or C++. At any event, the language includes references to things, specific functions that do things like, here it says current. If you're dealing with milliseconds, the millis function here tells you the number of milliseconds counted since the beginning. You can use that for timing. You can turn pins on and off. Here's a pin mode telling you that you set it to output, and then you write to the pin the state on or off, high or low. So that's how you basically turn an LED on and off using this language. I'm not really here to describe the entire language, but this is to turn an LED on and off. So I'm showing you how the program works basically. There are a couple of extra things here. There are variants of boards that you can use on this thing. I'm going to demonstrate a couple of them. I showed you a Diabolino, which is basically like an Arduino Duomo, and I'll show you. If you look under the Tools menu, you see the board selection. If I select Arduino Duomo or DS1000, that's compatible with the Diabolino. After it sets up, you look for the port And assuming you've plugged it in, you click on that and it enables the port. You see it's checked now. Now that the port's enabled and it knows which processor it's using, it can run the program. Now I showed you that it's blinking at about a half second rate. What I'm going to do is change the interval to 1 second by making it 1,000 milliseconds. I will save the program. I will verify the program to make sure I don't have any bugs in it. It should compile the sketch. The first time through it may take a little longer because it has to build a few caches. Then I upload the program and it runs to the Arduino. After it's run to the Arduino, you can see now that it blinks at a different rate. It's now blinking at 1,000 milliseconds, or 1 second on, 1 second off. So that proves that the program was uploaded and is running on the processor. I'm going to show you an example of an alternate form of microcontroller that can be used on this system. The Teensy by PGRC is another version of microcontroller that's also integrated into the Arduino environment. I'm going to plug it in. It's also running the same program. It's blinking at a half a second interval. But now I have to change the board because I'm no longer using an Arduino compatible. I'm using a Teensy 2 in this case. As you see, the Teensy is considerably smaller and works a little differently, but not only that, the port name is different. Instead of TTY USB 0, it's TTY ACM 0. It also has a special driver that pops up when I'm programming it. So if I now take the same program, I've got it compiled, I've got it written to do 1,000 seconds. Right now it's blinking half second on, half second off. If I verify, now it's going to recompile it using new libraries because it's dealing with a different processor. So it will change the program somewhat. The program was written in such a way, notice that it pops up this driver for the Teensy to upload to it. Notice that in the program itself, I have a macro defined to test for the core Teensy, which determines if it's a Teensy or not. If it's a Teensy, it sets the LED pin to pin 11. On an Arduino, the pin that's usually tied to the LED is 13. So it actually changes the program to go to a different pin. So now that it's verified and I know that it doesn't have any bugs in it, I'll hit upload to compile the sketch. It uploads and then you should see the light blink 1 second on, 1 second off. So I've just changed the program on the Teensy. I said the idea is you can do pretty much anything you can think of that's controlled by electronic hardware. You got on a standard Arduino, you're controlling 5-volt signals. You have 0 volts or 5 volts depending upon whether it's low or high. And you can read pins, you can read voltages with an analog to digital converter. There are a lot of things you can do with it. It's a very wonderful way. If you're learning programming, you're learning not just programming, but you're learning how to make things that do things in the real world. The Internet of Things is a buzzword now. You get to be in on that if you use something like this. The GLFPE gives you an environment in which you could do that. It's already set up and running for you. Don't need to worry about it. It's already there. You don't have to figure out how to put it together. You can concentrate on figuring out how to write your programs and make your projects work. Anyway, I hope this has been illuminating. Goodbye.